Bright Duty. Every student matters.
Find the probability of getting a head when a coin is tossed once. Also find the probability of getting a tail. Okay. Now, in a single throw of a coin, possible outcomes are head or tail. So, and we need to calculate probability of getting a head. So, we will write it like this: probability of getting a head. Now, there are only two possible outcomes, right? And probability of getting a head is equal to number of favorable events, number of favorable outcomes, or you can say divided by number of total outcomes. What is the favorable outcome in this case when we are calculating the probability of getting a head? This is the favorable outcome. What is this number of favorable outcomes? 1, right? What is the number of total outcomes? 2. So, this is the probability of getting a head. Now, we also need to comment about probability of getting a tail. So, this can also be done in this way. Probability of getting a tail is again number of favorable outcomes by number of total outcomes. What are the number of favorable outcomes in this case? This is the favorable outcome while we are calculating probability of getting a tail. So, 1 is favorable outcome, total number of outcomes is again 2. So, this is probability of getting a tail. Otherwise, you can also say when probability of getting a head is 1 by 2, probability of getting a tail is 1 minus 1 by 2. 1 is sum of all the probabilities of elementary events. Probability of getting a head plus probability of getting a tail is going to be equal to 1, right? We discussed in the introduction part that when we throw a coin, either you will get a head or a tail. So, it can be calculated this way also: 1 minus 1 by 2, that will again give you the same answer, right? Let us move to this second question here. A bag contains a red ball, a blue ball and a yellow ball. So, this bag contains 3 balls in total and these are of same size. Why is it mentioned that these are of same size? Because to show you that it is equally likely when you take out a ball without looking into it, it is equally likely that you get a yellow ball or a red ball or a blue ball. All these 3 events are equally likely. So, these are of same size. Kritika takes out a ball from the bag without looking into it. What is the probability that she takes out the yellow ball? So, total possible outcomes can be outlined like this: either you will get yellow ball, red ball or blue ball. So, number of possible outcomes is 3, right? 1, 2, 3. Now, let us look about the question. What is the probability that she takes out the yellow ball? So, subpart 1, probability of taking out the yellow ball is equal to, what are the number of favorable cases? It is 1 only, taking out the yellow ball. So, 1 divided by number of possible outcomes, which is 3. So, probability of taking out a yellow ball is 1 by 3. Look at subpart 2, probability of taking out red ball, possible outcomes again 3. So, in the denominator you will have 3. What are the number of favorable outcomes? It is only 1 when you get a red ball. So, 1 by 3. Third case, probability of getting a blue ball is again 1 by 3, right? These 3 are elementary events, right? And if you add these events, you will notice that it will give you 1. Right? Okay. Suppose we throw a die once, what is the probability of getting a number less than 4? what is the probability of getting a number less than or equal to 4? So, first of all, you should be clear in your mind about possible outcomes. When we are throwing or rolling a die, you will have 1, 2, 3, 4, 5 or 6 as possible outcomes. Now, what is the probability of getting a number less than 4? So, probability of getting a number less than 4 is equal to, what are the favorable outcomes here? If you get 1, is it favorable? Yes, because it is less than 4. If you get 2, it is again a favorable event. If you get 3, it is again a favorable event, because 3 is also lesser than 4. So, these are the only favorable events, because we are talking about less than 4, right. So, we cannot include 4 in it. So, these 3 outcomes are the favorable outcomes. So, favorable outcomes 3 divided by total number of outcomes, which is 6. So, 1 by 2 is the probability of getting a number less than 4. Now, this was the first part. What is the second part? Probability of getting a number less than or equal to 4. Getting a number less than or equal to 4 is equal to. Now, this time it is given less than or equal to. So, we can include 4 also. 4 is also a favorable outcome for us in this case. So, what are the favorable outcomes in second part here? If you get 1, it is less than 4, 2 less than 4, 3 is less than 4, 4 is equal to 4. So, these are the favorable outcomes. What is the number of favorable outcomes? 4. What is the total number of outcomes? 6. So, the probability is 2 by 3, right. So, this is how you will think about these questions. There is a question on cards now. One card is drawn from a well shuffled deck of 52 cards. Calculate the probability that card will be an ace. In the introduction, we studied about these cards, right. So, tell me, what are the total number of aces in a deck of cards? Total number of aces is equal to 4, right, in each of these categories: spades, diamonds, and spades, diamonds, hearts and clubs, right. Each of them will have one ace. So, what are the total number of aces? 4. Total number of cards? 52, right. So, probability of getting an ace is equal to, what are the favorable outcomes? What are the number of favorable outcomes in this case? 4. Why? Because if you get a ace of diamonds, right, it is a favorable event. If you get a ace of clubs, let us say, it is again a favorable event. So, there can be 4 favorable events. So, 4 events are favorable. What are the total number of events? When you draw a card, you can draw any card out of these 52 cards. So, 52 are the total number of outcomes. So, 4 by 52 is going to be the probability of getting an ace. Now, if you want to, this was part number 1. If you talk about part number 2, it is asking not to be an ace, getting not an ace, right, or card not to be an ace. It is equal to, so when you draw a card, right, when if it is not an ace, right, what will be the probability? You can calculate this probability in 2 ways. If it is not an ace, it can be any card out of the rest of 48 cards, right. So, it can be written like this, 48 by 52, because we have 48 cards in a deck of cards which are not aces, right. So, 48 by 52 is the probability of getting not an ace. So, this is equal to 12 by 13. Another way to look at it was getting not an ace is equal to 1 minus getting an ace. Right. So, it is also equal to 1 minus 1 by 13. Again it will give you 12 by 13 as your answer. Right. So, these were the two ways to calculate this. Now, there are two players, Sangeeta and Reshma, who play a tennis match. It is known that the probability of Sangeeta winning the match is 0.62. What is the probability of Reshma winning the match? Now, in this match, either one of them will win, right? It will not tie. So, one of them has to win. So, if Reshma doesn't win, then Sangeeta will win. If Sangeeta doesn't win, Reshma will win, right? So, probability of Sangeeta winning the match is given 0.62, and we need to find probability of Reshma winning. You can intuitively feel in this question that if in case Sangeeta doesn't win, Reshma will win, right? So, probability of Reshma winning is nothing but 1 minus probability of Sangeeta winning. So, it is equal to 1 minus 0.62, which is equal to 0.38. So, this is your answer. Or another way to think about it was, if you add the probabilities of Sangeeta winning and Reshma winning, it should be equal to 1, right? Because it is certain that one of them will win. Okay. Savita and Hamida are friends. What is the probability that both will have different birthdays or the same birthday? We are ignoring the leap year. So, we are talking about years which have 365 days, right? So, when you have 365 days, let us talk about part 1, which has got the different birthdays. Think about it. Let us say Savita has got her birthday on January 1st, right? And Hamida can have her birthday on any of the 364 days apart from January 1st to have a different birthday, right? Let us say one of these friends have a birthday on certain date. Think about it in your mind, right? Apart from that day, there are 364 other days on which other friend will have their birthday, right? So, to have two different birthdays, probability of having different birthdays is equal to, what are the number of favorable outcomes? Let us say one of these friends have her birthday on January 1st, right? So, 364 days are remaining. These are our favorable outcomes. So, 364 are the number of favorable outcomes. What are the total number of outcomes? 365. So, this is the probability of getting different birthdays, which is very high, right? This probability is very high. Now, let us talk about having the same birthday. Let us say Savita has got her birthday on January 1st. So, we are calculating the probability that Hamida also has her birthday on January 1st. So, out of these 365 days, there can be one day on which both will have their birthday, to have the same birthday, right? So, there is only one favorable outcome here. So, probability of having same birthday 1 by total outcomes 365. So, this is the probability of having same birthday. This you could have calculated by 1 minus this also, right? If they do not have different birthdays, they will have same birthday. So 1 minus probability of getting different birthdays is also 1 by 365, right. Now, there are 40 students in class 10 of a school, of whom 25 are girls, 15 are boys. So, let us write it here, girls 25, boys 15. The class teacher has to select one student as a class representative, right. She writes the name of each student on a separate card, the cards being identical, right. So, then she puts cards in a bag and stirs them thoroughly. She then draws one card from the bag. What is the probability that the name written on that card is the name of a girl, right. So, what are the total number of cards in that bag? 25 plus 15, 40, right. And what are the number of favorable cards? Number of favorable cards or outcomes. We are talking about part 1 here, when we need to see what is the probability of getting a card in the name of a girl. Number of favorable outcomes will be 25, because out of those 40 cards, there are 25 cards on which name of a girl is written. So, these are 25 favorable outcomes. What are the total outcomes? 25 plus 15, that is 40. So, it is equal to 5 by 8 number of favorable outcomes, or we can say number of favorable outcomes was 25 divided by number of total outcomes was 40. So, this is probability of getting a card in the name of a girl. So, probability of getting a card in the name of a boy is equal to, this can be calculated in two ways, 1 minus 5 by 8, because if it is not a girl card, then it will obviously be a boy card. So, it is equal to 3 by 8, right. Otherwise, you can calculate it in this manner also, number of favorable outcomes divided by number of total outcomes. When you draw a card, there are 15 cards which has got boy's name on it. So, 15 favorable outcomes are there and total number of cards is 40, right. So, 5 3s are 15, 5 8s are 40. So, it will give you same answer 3 by 8, right. Okay. Now, there is a box which contains 3 blue, 2 white, 4 red marbles. If a marble is drawn at random from the box, what is the probability that it will be white, blue or red? So, again we will look at probability of getting white marble is equal to number of favorable cases divided by number of total cases. When I say cases, I mean outcomes, right. What is the number of favorable cases? How will you count that? When you are calculating probability of getting a white marble, these are our favorable cases, right. What is the number of favorable cases? We have got 2 marbles, 2 white marbles, right. So, 2 is the number of favorable cases. Total number of cases is 3 plus 2 plus 4. So, what is 3 plus 2 plus 4? It is equal to 9. So, probability of getting a white marble from this bag or box is 2 by 9. Second case, probability of getting a blue marble. What are the total number of favorable cases in case of blue marbles? 3. Total number of cases 9. So, it is equal to 1 by 3. And third question is probability of getting a red marble. What are the favorable cases? 4, because we have got 4 red marbles. So, 4 by total number of outcomes, which is 9. So 4 by 9. So these are the probabilities. Okay. Now you can also notice that if you add probability of white, probability of blue plus probability of red marble, what is the answer? 2 by 9 plus 3 by 9 plus 4 by 9. It is going to be equal to 9 by 9, that is equal to 1, right? So what does it show? That when you draw a marble from this bag, it will either be white or blue or red. So it is certain that you will get any of these three, right? So sum of these three probabilities is going to be equal to 1. Harpreet tosses two different coins simultaneously. Say one is of rupee 1, one is of rupees 2. What is the probability that she gets at least one head? Okay. You remember tossing of two coins simultaneously. Possible outcomes. What are the possible outcomes? First coin, head, second head, first head, second tail, first tail, second head, first tail, second tails. These are the possible outcomes, right? First coin shows you head, second shows you head. So we discussed it in the introduction, right? Now what is the question? Getting at least one head. You need to take care of the language that the question is using. We are talking about at least one head. So one head is also favorable, two heads are also favorable. So probability of getting at least one head is equal to number of, what are the number of total outcomes? 1, 2, 3, 4. So number of total outcomes is 4. What are the favorable outcomes? We need to talk about at least one head. So there is one head in this outcome, this is favorable outcome. There is one head in this outcome, so this is also favorable. Now there are two heads in this outcome. Is this favorable? Yes, because we are talking about at least one head. This has got two heads, right? So it satisfies our condition. So there are three favorable outcomes here. So probability of getting at least one head is 3 by 4. In a musical chair game, a person playing the music has been advised to stop playing the music any time within 2 minutes after she starts playing. What is the probability that music will stop within first half minute after starting? Let us consider this line as 2 minutes, right? So this period is of 2 minutes, let us say. Right? In every question we won't be able to exactly count the possible number of outcomes and favorable number of outcomes. So in such questions we have to devise certain other method. Let us look at this question first, then we will discuss about it. So there are total time is 2 minutes, and what is the probability that the music will stop within first half minute after starting? So let us say this is 1 minute and this is half a minute. Okay, and we need to calculate the probability that the music stops in this period, right? So you need to look at this as like this. What is the total span of time that is available? That is 2 minutes, right? And what is this span which is favorable in our question here? Because we need to calculate probability that music stops in first half minute. So this span is favorable span for us, right? So this is half a minute. Okay, so probability is equal to the favorable span of time divided by this total time, which is 2. So it is equal to 1 by 4, right? So this is 1 by 4. These are the questions which you can calculate by visualizing these figures. There can be questions based on favorable area of a certain figure, right? Okay. Here comes a question based on area. A missing helicopter is reported to have crashed somewhere in the rectangular region. What is the probability that it crashed inside the lake shown in this figure? So you look at this figure, there is a lake on this, on a corner on this rectangle, right? We can calculate the area of this lake. Let us talk about total area of the rectangular region. Why I am calculating total area of rectangular region? Because this is total possible area where this could have been, this helicopter could have been missing, right? Or this helicopter could have been crashed, unfortunately. So this is the total area of rectangular region. It will denote the total possible area where it could have crashed. So it will act like the total possible outcomes for us. So total area of the rectangular region is length into breadth. So length is 9, right? This is 9, and breadth is 4.5. So it is equal to 9 into 4.5, which is equal to 40.5, and the unit is kilometer square. So this is the total area, total possible area. What is the, let us say, favorable outcome? We are talking about mathematical language here, right? In this question, we are talking about crashed helicopter. So let us think about from the mathematics perspective. So what is the favorable outcome? That it crashes in the lake. So let us talk about area of the lake here. It is equal to, what is the length here? Length is 9 minus 6, that is 3 kilometer. What is the breadth? It is 4.5 minus 2, which is equal to 2.5. So area of the lake is 3 into 2.5, which is equal to 7.5 kilometer square, right? So what is the probability that the helicopter crashed in the lake? It is equal to area of the lake divided by total area. So it is equal to 7.5 divided by 40.5, so which can be written as 75 divided by 405, right? So 15 5s are 75, 15 2s are 30, 15 7s are 105. So it is equal to 5 by 27. Okay, so this is the probability in this case. Now there is a carton which consists of 100 shirts. Okay, there is a carton which has got 100 shirts in total, out of which 88 are good. So 88 are good shirts. 8 have minor defects. 8 have minor defects. 4 have major defects. So 4 shirts have major defects, right? Jimmy, a trader, will only accept the shirts which are good, but Sujata, another trader, will only reject the shirts which have major defects. So one shirt is drawn at random from the carton. What is the probability that it is acceptable to Jimmy? So probability that the shirt is acceptable to Jimmy. So when it comes to Jimmy, what are the favorable cases? Jimmy accepts the shirts which are good. So Jimmy will accept only these shirts out of these total shirts. So what are the favorable outcomes here? 88. What is the total number of outcomes? 100 because we have got total of 100 shirts, right. So, this is the probability of getting that shirt accepted by Jimmy. So, this is 4 2s are 8 2 22 by 25. Second question says probability of a shirt being acceptable to Sujata. Right? You write the correct spelling here. So, probability of shirt being acceptable to Sujata is, what are the favorable cases this time? See, look at Sujata here. She will only reject the shirts which have major defects. So, good shirts are also acceptable, shirts with minor defects are also acceptable to her. So, what are the total number of favorable cases? 88 plus 8 here, which is 96, and she will reject only these shirts. So, what are the total number of cases? 100. So, this is the probability that the shirt will be acceptable to Sujata. You can further simplify it by dividing it by 4 on numerator and denominator both. (24 by 25) it is, right. So, this is the probability of shirt being acceptable to Sujata. Okay. We have got two dice, one blue and one red. These are thrown at the same time. Write down all the possible outcomes. What is the probability that the sum of the two numbers appearing on the top of dice is 8, 13, less than or equal to 12. So, let us say we throw two dice, one is blue here, one is red, right. So, I discussed in the introduction part that blue can give outcomes 1, 2, 3, 4, 5, 6. Red can also give 1, 2, 3, 4, 5, 6, right. But when we are throwing these simultaneously and looking at the top of both the dice, then we can say the possible outcomes are, first die shows you 1, second shows you 1. First shows you 1, second shows you 2, 1, 3. 1, 4, 1, 5, 1, 6, right. So, this is the kind of table that you can make. First shows you, or we will use this bracket here. First shows you 2, second 1. First shows you 3, second 1. First shows you 4, second shows you 1. First shows you 5, second shows you 1. First 6, second 1, right. Keep on doing like this. 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, right. Or what you can do is you can make a table also, right, like this. You just write 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5, 6 here, right. So, here you will have 1, 1. Here you will have 1, 2. First, this is row, this is column, right. So, this will give you 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, right. So, these are the total possible outcomes, right, which are possible. what is the total number here? If you count this manually, or you can do 6 into 6. So, these are total number of outcomes is equal to 36, right. So, this is how you will write these outcomes. Now, let us look at the question. What is the probability that sum of the two numbers appearing on the top of the dice is? Let us say on the first die, this number appears 2. On the second die, it appears 4 on the top. So, what is the sum? 2 plus 4 is 6. So, we are talking about this sum here. So, what is the probability that sum of two numbers is 8? Look at these cases here. If 1 shows on the first die, can 7 show on the second die to make this sum 8? No, because 7 is not possible, right. So, on first die, if 2 shows, on second die 6, it will be a favorable event. First die, if 3 is there, on second die 5 will have to be there. If first shows 4, second will have to show 4 to make the sum 8. If first shows 5, second will have to show 3. If first shows 6, second will have to show 2, right. So, these are the favorable outcomes, right, or you can select these outcomes from here also. If you look at this here, these are the favorable outcomes. In these cases, this sum on the top of these dice is 8. So, what is the number of favorable outcomes? So, let us talk about probability directly. Probability of getting the sum equal to 8. It is equal to number of favorable cases 1, 2, 3, 4, 5 divided by number of total cases 36. So, this is the probability of getting the sum equal to 8. Probability of getting the sum equal to 13. Look at these cases here. Even if you get maximum number on both the dice, let us say you get 6 on the first die and 6 on the second die. So, what will be the sum? It will be equal to 12, right. We cannot go beyond 12, right. So, what is the sum? Maximum sum that we can get? It is 12. So, probability of getting a sum of 13, probability of getting the sum equal to 13 is 0, right, because 0 favorable outcomes are there. There is no outcome in which we can get a sum of 13. So, probability will also be equal to 0 because this is an impossible event. Let us talk about this less than or equal to 12. What is the maximum sum? It is 12. What is the minimum sum? It is 2. So, sum will in every case it will be less than or equal to 12. So, it is certain event that you will get a sum less than or equal to 12. So, the probability is going to be equal to 1 because all 36 cases are favorable cases, right. So, 36 by 36 you will get 1. So, this was about probability of certain event, right. So, this was about our first chapter here, first exercise of probability, right. I hope you have understood the concepts of probability and these questions also. In the next lecture, we will cover the exercise on basis of the same concepts. Thank you.